Computer. All right. Sounds like we got quite a few folks signed up today. I'm really excited to talk about 12-factor agents. How many of you read the blog post? Did everyone read it so far that Dexter made?
Nope.
Oh, you're in for a real treat. The
Oh, this
12-factor
is gonna be a good
is
time.
one of the most fun blog posts that I've read in a while. Um, and it's this interesting concept that we had percolated on for quite a while. And then Dexter just put it down to like these beautiful words to really help outline it in a more concrete way.
Well, yeah, I think I kind of stumbled on this. I think you and me did a hackathon back in like October or November, and we were building agents and we were building them from scratch. Uh, and that was kind of the seed and the initial idea there that I then went and hacked on and talked to a ton of founders and was just trying to figure out what makes good agents and like how can we can distill this down into building blocks.
Yeah. Yeah. Like the building blocks, I think that's really what's missing right now.
Well, and so the problem with not having good building blocks, I think, is I know we said we're going to wait till people got here, but I'm just going to start going. The problem with not having good
Into
building
it,
blocks is I
totally.
think you end up with this problem of you're like, oh, I want to build something pretty cool with AI. I want to build something agentic. I want to do something a little bit more than just a chatbot or summarization of my web app. And so you're like, cool, we need an agent. Like, okay, like I don't want to write all this code from scratch, maybe learn it all from scratch. Maybe you do. Some people do. But a lot of folks are like, cool, let's go get some frameworks and some libraries. And I think what it leads you down this path of like, hey, let's build rather than like just making our existing software a little more AI integrated, you end up with people who are just like, hey, let's go build something from scratch. We're building our agent. We have our thing now and we're gonna go do greenfield from scratch, build an agent. And I think what happens is that never works. And what I wanted to figure out was like, how can I help people who already have really good software and have ideas about how AI could make it better? And what things did they need to take from the agent paradigm that they can take one by one, that they can take piecemeal, that they can kind of like just carve up this problem and slowly over time take deterministic code and sprinkle in some LLM calls in the right places to make it really like magical without tanking the quality or making it unreliable or having this sort of like chat GPT hallucination effect where like 1 in 5 times you're like, oh, this is useless. This is never going to work.
Yeah, I agree. Let's all right, it's 10:04. Let's do a quick little brief background, who we are, to everyone that's on the call, and then let's get into it and like what this thing is about. So
Cool.
I'm Vaibhav. I'm one of the co-creators of BAML. I'm a YC founder from Winter 23. And this is my co-host, I guess. Go for it.
What's up? I'm Dex. I'm the founder of Human Layer, another YC company. We are working on safer, more reliable agents and how to build agents that can actually get real, meaningful work done.
Yeah.
And yeah,
And the whole point of
uh,
the
yeah,
series that we've got here is really just we all see a lot of demos that come with AI, and we'd like to go past the demo stage. We've seen between Dex and I, we've seen like probably hundreds of companies that have actually shipped to production and found patterns that work, and we've found our own techniques that work. And we just want to use this session to go share some of those, and not really at a high level, but really at the layer of code. Because honestly, it's just there's a lot of things that talk about the words behind the AI, but there's not a lot of stuff that talks about the code that we have to go write. And that's the whole point of these sessions. So as you guys have any questions, please go ahead and post them in the chat, or if you really want, you're welcome to unmute and go ask questions as you go. What we're going to go do is typically we include a whiteboard session, and then we also include some coding sessions because whiteboards are just a great way to convey ideas before the code. So be patient, you will see code, we promise. But also the whiteboarding is just to help contextualize and make sure we're on the same page. Cool.
awesome.
Let's go to
Um,
today's
I
session.
think let's get into it. Little preface: there will be some question. Yeah.
Please.
Okay, let's go on. Dex, let's go
All
to
right, we're gonna
12
keep
factor
rolling.
agents. Let's go into 12 factor
Cool,
agents. You want to screen share
cool.
and pull it up.
Yep, I'm gonna screen share, and there's gonna be a little bit less what I would call let's see. A little bit less of what I would call the like hands-on live whiteboarding, just because there's a lot of content to cover. And so I'm going to jump through kind of a little bit more of a slideshow kind of thing. But this is all the content in the repo. You can see all of this. So I want to start with kind of like a little bit of like how we got here and how to think about writing code and software. And this is a concept here. This like software is a directed graph, because there's a lot of like frameworks today that help you think in graphs. But at the end of the day, code is a graph. And the theme we're going to keep coming back to here is you want to have control over the code. You want to have hands in the code because that's what gives you the control to add probes and changes and tests and things to help you improve the quality. Um, After a while, we ended up with these things we call like DAG orchestrators. If you're familiar with your like prefects or your airflows or your Dagsters, these sorts of things where each one of these nodes, it's still a directed graph. You still have logic that is moving information, whether it's variables or data in a pipeline through different steps. And it's very declarative and deterministic. The promise of agents is essentially like the real hyper on agents is you can take an LLM, you can give it a bag of tools. You can say like, here's all the steps you could take. I'm not going to tell you which steps to take and which order to do it in, but here's your goal and here's the steps you can take, and like go figure it out basically. And that the LLM will traverse the graph, figure out which steps to take in which order, and get to that goal. And it might skip some steps as well. It might not need to take all the steps. And the idea here is, cool, now I have to write a lot less software, whether it's like a DAG that is in code or it's a DAG that's in my infrastructure. Conceptually, the agent's going to figure out the ifs and the logic and the looping for me instead of me having to go write all of that and test it and make sure it's really, really good. And as LLMs get smarter, they'll be able to handle more and more complex workflows. And the way we model this, especially when we talk about like agents and structured outputs, is essentially like an agent is just a prompt that determines the next step. And so you have an event and you say, hey, LLM, what's the next step with this event? And then the LLM might say, okay, we have to call this API, or we have to kick off this pipeline, or we have to update this database. Or maybe it's like, cool, we're done. We've done those things and now we're finished.
And just
And the
like,
way this kind of, sorry, go ahead.
just to really highlight to a lot of people, it's like a lot of people use this word of like the agent is calling the tool. It's not calling the tool. An LLM is really just a really, really smart go-to statement. Like in our code, we used to write
Yep.
go-to statement. That's really all this boils down to.
I love that you said go to, because I literally have a blog post I want to write that is like, do you remember that post that was go to considered harmful?
Yeah. It's that's
So
what an LLM is.
I actually think the concept of tool use is harmful. The idea that a model is smart and is interacting with its environment is
Yeah.
actually like, it's a little bit of hype. I mean, it's, you can think about it in that way, and it's a good way to like introduce the concept. But at the end of the day, when a model calls a tool, it's taking a bunch of input tokens as the prompt, and maybe some tokens about what's happened so far, and it's outputting JSON that says, I think the next step in this workflow is X.
We should play the
And
video. That one's
yeah. So the way this works as you kind of move through this stuff is you would kind of like pick a step, call an API, and then add that to the context window, feed that new context window in. It says, okay, we had this event, we called this API, we got a result. Then the LLM is going to say like, okay, cool. With that result, I can now kick off a pipeline and get the results of that. And then we add that to the context window. We feed it back into the LLM, and we update the database and we get the result. And then we add that to the context window. And then the LLM may say, cool, we've done our job based on the event, based on the goal, this is super generic. But every time you do a tool calling, and if you've built these tool calling loops with the OpenAI APIs or the Anthropic APIs, like this will seem super familiar. We just want to break this down conceptually into, what is this really? Bob, what's the shortcut for opening the file
Command B.
browser?
Command B. Command B.
I'm trying that. Yeah, there we go. Okay, cool. Thank you. So in this kind of like dynamic loop, what was materialized is this DAG, right? The agent figured out the DAG for us. We did this step, and then we did this step, and then we did this step, and at the end of the day, that's kind of what happened. If we come back to this loop, there's basically four components, right? You have a prompt, and then the prompt's going to output JSON. You have a switch statement, which is going to basically say, based on the JSON that was output, which code path do we want to go down, or do we want to exit? And then you have how you're building, how you tell the model, again, because this is totally stateless. The only way it knows what happened in the past is if you pass in tokens, strings, JSON, XML, whatever it is, and tell it what happened before so it can make the decision of the next step, and then you have a for loop. The whole idea behind 12-factor agents is really like, you're a good engineer, I hope, probably. You can write a switch statement. You can write a for loop, and you can turn some data into a string. And the most important part that's going to control how good your agent is and how good the performance is this prompt. The prompt of how to behave, how to do it, what's the context that we put in, and how to call these tools, the description of the JSON that you're asking it to output.
And I want to highlight one thing here. A lot of people I know what you mean when you say prompt, but I think a lot of people are going to assume that prompt means a system prompt, all the stuff. That is not what Dextre means. Just to highlight that again. What Dextre is trying to say is it's the full serialization of the state. We talked about this determined next step being completely stateless.
Yeah.
Context that you're putting into it, somehow you turn that context into a where are you going to the whiteboard? Somehow you're going to turn that context into a string. Somehow you're going to include instructions for what you want the model to do. Somehow you're going to model the exact outputs you want the model to output. All of those things together are the prompt. It is not individualistic. It is not simply to say exactly what the system prompt is. It is everything together. That is what Dextre is trying to highlight of what the prompt is. And even here, where you were using the word system and user prompt, because that's just terminology people have used, you may find that putting the entire context into the pure system prompt is going to get you the best response. You may find putting instructions in the user prompt gets you the best response. Even that itself, whether you use the system prompt or the user prompt or what tokens you're using to represent this, dramatically makes a difference. And being aware of that fact of like what you're doing here is somehow you're taking a data model that you have that represents a state that you save in your database and turning it into an API call that matches the best output format that you want somehow. That's
And the point is not to kind of say there's a right way to do this or there's a right thing to do here. The point is, if you think of this whole thing as just one big string, you can do anything you want with this. And I don't know what the best way to handle the prompt for your specific problem, but I know that if you don't have full control over what goes in there, in what order, with what special tokens, you may be missing out on optimizations that you could make. And so the more control you have, the more ability you have to customize all of this and to take full control, the more likely you're going to be able to get to the best performance for a given task that a model could get. And that's all that we talk about in this show is how do we get the best possible performance out of today's models?
Yeah, that's perfect.
Yeah, and we'll get into kind of as the models get smarter as well. But I'm going to quickly run through the 12 factors as we talk about them, and we may pause on a couple of them to go a little bit deeper. But from there, we'll get into some code. So number one is like natural language becoming tool calls. And this one's really, really straightforward, but it's basically, taking words from a human and turning them into JSON. That's all we're going to do. And we'll go through this in the demo. But being able to take human words and turn them into actions in the world.
Carlos has a question. Does that mean ditch the frameworks?
Yeah.
We'll talk about frameworks in a second.
Yeah.
We'll have a second coming out about
nobody
this.
Here is saying ditch the frameworks. I actually think of a lot of this here as like feature requests or like a letter to the builders of frameworks of like the kinds of control knobs that I think they should be exposing.
Yeah.
Factor two is own your prompts. This is what we just talked about, basically. Like rather than building abstractions around something that's going to build you a great prompt, you can hit a framework like LangChain, like CrewAI. They all have really, really good prompt engineering primitives built in. And if you're not a good prompt engineer like me, I'm a shitty prompt engineer. You'll see Vaibhav shout at me for my prompts later today. You can turn some like high level sentences into a banger prompt, which like you'd need months to go to prompt school to learn. I don't know if there's a prompt school, but Vaibhav, if you're thinking of other schools to do. Um, but eventually, like with the black box, you're going to hit the limits and you're going to be reverse engineering. Okay, how does this prompt get built and how do I flip these tokens around so that it happens in the order that I think is actually going to be better? And so at the end of the day, it's really just worth like full ownership.
Yeah, it's just like it's not about addition to framework. What you really want, you probably don't want to build a prompt from raw strings on your own, but you also don't want a framework that makes it harder for you to own the prompt. That's really what I would look for. Like, how closely do you own the prompt and how much control do you have over the final prompt that is being sent out?
Yeah. And again, I don't know what's better, but I know you want to be able to try everything.
Yeah.
Cool. The other one is own your context building. This is, when we say prompt, like this is a kind of a subset of that, but it's a very specialized one because I think a lot of people think of tool calling and context building as separate from prompting, but it's all just tokens going into the model. So if you want to use the standard format of like system, user, assistant, tool, and like you're giving it back and forth in this official format, you could do that. But in this moment, when you're giving the model a prompt, your only job is to tell the model what happened so far and ask it what the next step should be. And you can put all of the events of like, hey, what's the weather in Tokyo? Hey, we did a check weather call. Hey, we got a response, ask the next step, and then we would probably get our final answer. You can do that all in one user message if it works better. And I don't know what's better.
Every model is a tool calling model is the way to think about it, as long as you can describe your tools in a good way.
Yes, exactly. Tools are just structured output. A lot of these are clearly like related and come together. But whether you're telling OpenAI with a JSON schema to output a function call to a certain function, or you're using something like BAML to just ask it to output JSON plain, it's all just part of the prompt and then what you do with the output and parsing it and turning it into structured data for your model to use. Let's find this one. Yeah. So all you have to do is get JSON out of the model. And so thinking about this in terms of special tools or special functions can be sometimes a little bit counterproductive.
Yeah. Instead of calling a tool, it's just honestly way easier to say it's a type that I want the model to produce. I want the model to return a class. I want the model to return an array instead of using the special word tool, because we have tooling for all the other things, type systems in the past.
Yep. Cool. Here's another one. Unify execution state and business state. I'm actually going to do the animation for this one. But basically, as you are iterating through this flow and you have your different JSON outputs, being able to serialize what's happened so far, your context window that you're passing into the model, is not just like the business state of what is the model thinking about and what the logic is, but if you should trivially like make the context window itself be a representation of your execution state as well. A lot of these frameworks, like if you look at something like LangGraph, which I think is very good for a lot of reasons, but you have kind of two states here. You have the graph state, and then you have the the object that flows. You have your business state, right? You have like the object that flows through the graph, and this is usually like some struct that is just like messages. And it's a list of messages. And you can store other things on here as well, like, pending tool calls or something like that. But basically your like business state of what the model operates on is separate from this big, I don't have a screenshot of it, but there's this huge, like a bunch of tables that go into SQLite or Postgres or whatever it is that kind of outline every single step that's been taken. If you can unify these things, you're going to simplify a lot. There may still be reasons to have this. And this gets back into like own your context window. If you have an object that you control that tracks like the state of your application, you can put methods on it that tell, hey, when we send it to the model, just send it this way. Like, here's how you serialize this for the LLM versus here's how you serialize this for RAG versus here's how you actually like use this to pump the execution state. So it's all about control. But if you unify those things, then you can get a lot of simplicity, and this is what a lot of people are doing in terms of just like
I think
building AI agents in production. Go ahead.
the best analogy for this kind of stuff is, I don't know if any of you have ever worked on like massively online multiplayer games, but like the way you build these systems is that they're built to have a unified state of source of truth. And then you basically use that as the thing that everyone views and renders. You view that as the thing that everyone that builds and renders, and that's just the easiest. If you have like 7 different objects that represent the source of truth, you have discrepancies, you have untruths, and you have a really hard time representing the data. But if you have a single state, debugging and everything else, building, maintaining your systems becomes a lot easier. And that simplicity is really, really important.
Yeah, nailed it. Cool. We're gonna keep running. Again, what this lets you do is you can pause and resume with like very simple APIs. So as you're running through this workflow and your model is maybe, you launch a workflow over REST or MCP, and that causes some kind of context to be input into the model. Maybe it calls a long-running tool and you need to kind of like interrupt or pause your workflow. That's great. Store your context in the database and the fact that you most recently called a long-running tool. And then basically when the job is finished, you would post a webhook back, use that to pull the state out of the database, and then take the result and push it onto the thing and send it back into the model. Man, I wish that thing paused. I think this is it. Yeah. So essentially like resume later using a state ID, that tells it how to pull the context out of the database, and then you take the job result. And so you can build, if you own this logic here, this API endpoint, you can catch a webhook, you can reassemble the context from the past, you can append the result to it, push it right back into the model, and there's no other execution system. There's no, distributed workflow system that you also have to go integrate into, because all we care about is our context window.
Exactly. And because it's a stateless function, it doesn't matter. It's really easy to make everything work.
Yeah, LLMs are stateless. The only state is basically this context window, which is also nice because it's very inspectable. Like as a human, you can look at it and see, okay, here's what's happening. Here's where it got stuck. Here's where it's looping on an error, whatever it is.
Exactly. And as a developer, that means you can build UIs for your tool, for your customers as well, to see exactly what's happening on a long running async task.
Cool. Yeah. This one's subtle. I think we could do a whole 20-minute on just this one. But basically, when a model is making a decision about whether to output a tool call or whether to output plain text, there's like a very, very like high weighted like token choice, which is like the JSON token or the I'm going to contact a human token. Or sorry, not contacting you, but I'm going to output my answer that goes to the chat UI or wherever it is. And what I've seen a lot of people doing is, one, there are different reasons you might want to send a note to a human, whether it's like requesting clarification or a final answer. And there's also different like types of humans a model might want to contact. And if you want like better AI experiences, you need to give the model the option to involve multiple players. And so you have standard tool calls like call a function that's deterministic, but then you basically are having the model declare its intent before it goes in. So it's always outputting JSON, and you have a little bit more focus on basically this string of what do we want to do next versus do I want to call a tool or say something to a human. Does that make sense, Bob?
I think you're saying almost the right thing. And just like really clarify, I know we keep saying like JSON. What we really mean is we're just outputting some specific structure that we want. There's many ways to do the structure.
Yeah.
Like JSON is one technique that a lot of people know commonly, but there are other techniques that can make it better. But I think what like representing everything as a tool of like intent and giving the model some way to go do that, then definitely yes.
Yeah, cool.
And there's no such, Carlos, that's a great question. Can a human be a tool? So it's universal. There's no such thing as universality with the world of LLMs. There's no, when you go to Google search, and when I search for like, how do I print a string? How do I do like a print statement? I use a lot of Rust code. Google will show me mostly Rust results. When someone anonymous goes and search, it'll probably show them Python or JavaScript. There's no universality. And for your users and your tooling, You might be using the most average tool, so maybe we can just call it a human. But the more specific you can make it, the more control that you are taking over your system, the more accurate and better experience you'll provide to your users. But it's all about testing and iterating. Anyone
All right, we
claiming
got
the best tool is probably not correct because they just don't have the data for your use
yep.
case.
Okay, we got 5 more minutes for slides, and then we're gonna jump into code. So I'm gonna fly through some more of these. Control flow. I mean, we've kind of hinted on this a lot, but basically, if you own your control flow, if you own that switch statement, you can decide when to break out into another workflow, when to pause and resume later. When these are all kind of like complement each other, but the idea is you can pick 2 or 3 of them at a time and start incorporating them. And so if you own the switch statement, you can insert little like modes to summarize things or add an LLM as a judge to break out and bring things back in. You can pause and do something asynchronous and then resume later. So this is kind of, we've gone over this one a little bit. Another thing that I think is worth mentioning is this like adding errors onto the context window. If a model calls a tool and that tool is bad, either the API is down or it used bad parameters or whatever it is, let's say that result caused an error. We can put that on the context window and hand it back to the LLM and have it say, like, let's try again. And then maybe that will give it enough to get to success. Super simple concept. Almost every framework already does this. But that's another interesting one that we talk about a lot. The next one is kind of small focused agents. Again, the longer and bigger you have this like workflow owned by the agent, the more tools you have and the more steps you have, the more likely this thing's going to spin out and fail. You may say like, well, what if the agents get smarter? This is kind of how I see all this progressing, where you have a fully deterministic workflow, you replace small parts of it with agents, and then over time, you can get bigger and more interesting agents, and they start to overlap. And maybe in a couple years, say what?
And I think this point, what Dexter is saying is that like
Yeah.
when these principles that we're sharing here are not just about like models getting better, like Sam Altman might tell you that we have to go wait for the better model and it's going to go do everything. But that just means that the box gets bigger, like this visualization shows.
Yeah. And I
Doesn't
think
remove the need for the box.
yeah. And I think even as the models get smarter and you can get better results with less engineering, there will always be tips and tricks that will help you get more out of a given model. And I think the Notebook LM team put this really well. I haven't seen anything on Notebook LM in a while, but when they launched, it was super popular. And the reason why it was is because, in their own words, the only way to create really impressive or even like magical experiences in AI is to find something that is right at the boundary of what the model is capable of and get it right consistently.
Yeah.
And so even as the model gets smarter and you don't need to do so much engineering, if you want to do something that is 10x better than what already exists, you are going to want to do some engineering and you're going to have the flexibility to be intentional about this.
And to give everyone like an analogy that I think is relevant to like current software is technically most websites are really just the same thing, the different views on similar databases. The way people interface with it makes a huge difference. And because it
I like
just
that.
the way that you react to a site and the way that you see the data. The same is going to be
Yep.
true for your agentic systems. Like we're all using the same models. Claude Code versus Cursor. They're both using Sonnet 3.7. There's no difference.
It's
But
just the UX and all the engineering in between.
exactly. That is the only thing. So like if you want to make a differentiated product, there's no moat in saying I'm going to use the best model. Everyone has the best model. You assume that and assume people have a better model than you.
Yep.
Make a better product anyway, and do that with engineering.
Cool. All right, we're gonna speed through the last few of these. So yeah, factor 11, trigger from anywhere, meet users where they are. I think ChatGPT is the like GeoCities era of like AI UXs. There's gonna be a lot better ways to interact with AI. I think a lot of people who are building really impressive things are building AIs that you can interact with fully from your email inbox, from Slack, from lots of places beyond just a web application. And this one's a bit of a meme, but it's kind of the culmination of everything else that we've been talking about, which is, LLMs are stateless. agents can be stateless. You're just operating on a context window. And actually, someone commented on LinkedIn. I think it's actually because there's multiple steps. It's a transducer, not a reducer. But
Maybe,
that's kind of a good
maybe,
summary.
maybe.
All
Okay.
right.
Before
We
we
can
go
get into
into the
that
rest
one
of it,
later.
1 second.
Yeah.
I just want to appreciate one thing for everyone. Can we appreciate that the naming that Dex used was hex code? That is amazing. On your file system.
Well, I wanted it to sort. I wanted it to make sure
No,
it's
I
still
get it. I
sorted.
get it. So I want everyone to just appreciate that. All right, quick little thing. And then can you go to the browser really fast, your drawing thing? I just want to
Yeah, the
draw.
whiteboard.
Yeah, someone asked a really good question that I think is relevant and going to help us out. So the question
Cool.
that someone asked, Jonathan asked, like, what's the advantage of using small number of big agents versus a large number of smaller agents? And I think the analogy that everyone should use is that these systems are really about like these systems are all fallible, they fail all the time. So let's look at if we use a small number of big agents, you end up with a curve that looks like this. You have some distribution of how well it works, and you have a wider array of things that you might work well on, but you also have a wider array of things you will work poorly on. If you use a large number of small agents, then you basically change the distribution to look like this. You will work better in certain areas, and you may not work as broadly, but if you build it really well, you can actually make a curve. The more engineering you put into it, you can basically change that curve into something that looks like this. You can make it wider and taller as you wish. And that's really the difference. It's like the amount of engineering effort you put into it. The orange curve is no engineering effort, let the model do everything. The green curve is some engineering effort. The red curve or pink curve, I can't see, on my screen's pink, is more engineering effort, and that's how you scale up these systems. It's like databases. The way you make a database go scale to like 5 nines, you just put more engineering behind it. You can make it really damn good. It just umpteenth amount of engineering, and the same thing is true here. Hopefully it answers something.
Awesome. All right, let's write some code.
Let's write some code. This is my favorite part.
Okay, cool. So what I have here is a empty TypeScript project. We're gonna do TypeScript today because I won the coin flip, and we've been doing a lot of Python lately. So what I'm gonna do is I'm gonna just start grabbing files for this walkthrough. We're gonna start with just a really simple hello world. So literally, here's our script. I can run it with let me make that term a little bit bigger. So if I run this script, it just prints hello world, right? Great. We can commit that. That's all we've done so far. Sorry. The next thing I'm going to do is I'm going to install BAML, which is what we'll be using for prompting our agent and building our determine next step prompt. And there is one default file that comes when you do that BAML in it that is the resume that I'm going to close out. So now we have in our BAML source, we have clients, which is things that talk to LLMs, and then we have generators, which is some BAML config. I'm going to write a really simple agent here that basically just has one tool call, which is, we'll call it done for now, but it's basically respond to the user. And so, yeah. Yep. So we have a prompt called determine next step. And it is basically can return one type, which is done for now, where the model will declare its intent, and then we'll just get the message that it wants to send.
You want to zoom out a little bit?
Yeah.
There we go. Cool.
There we go.
And do you want to click on open playground so people can just read the prompt fully for that one test case a little bit better?
Yeah.
Yeah. Okay.
Yeah, there you go. So the system message is you're a helpful assistant. We'll go in and show you how, like, as an example, we'll add reasoning and some fancy stuff to this prompt. We'll add more tools and types to it. But you can basically say, hey, you're working on this thread. If we wanted to test this or play with this, we can run it and it says, hey, here's our answer. So if we wanted to give it other instructions like talk like a pirate, we can save this and we can run it again. And now it's going to talk like a pirate. Great.
And I want to highlight this. This is one of your factors. Respond to agents with tools. Instead of having it just respond as a string, we could change the return type of determine next step to not be done for now, but instead be a string. Can you make that a string type and press play? We could do this. Like that's totally a valid way to do this. But by using a tool, we're able to get a couple of wins for our users, which is now we can just render the dot message field to the user.
Exactly. So I'm going to generate the models for this, the TypeScript code for this. And then I'm going to enable the BAML debug logging.
Oh,
And
yeah.
I'm going to add a couple of TypeScript files. So we're going to add a CLI, which basically just pulls a user message off the command line, turns it into this thread object that we'll get into a sec, and sends it to our agent. And then our index.ts is going to call that CLI function. The agent itself is pretty simple. I'm going to start here. This is called agent loop. This actually doesn't do any, oops, sorry, let me close that out. This doesn't do any looping yet. It's just going to call our determine next step, and then it's going to return it. We have this thread object, which is just a list of events, which we'll get into, but this is like the items in our context window. And so when I run this, quickly, I'll show you if we can say hello. What happens is we have kind of the BAML logs will actually output the prompt that was passed in. So here's the thread we actually gave to the agent in our determine next step prompt. We serialize that for the agent, and then so we build this thread and it gets passed in as JSON. And then we ask it what the schema should be, and it says cool. So I can say, you know, hello, talk like a pirate. This is the best LLM example that exists. There we go. So now it output this thing and we just kind of print it out.
And
So that's our literally natural language to tool calls. The only tool right now is done for now, but we'll add more tools in a sec.
Carl, while you get your next step set up, I'll describe.
Yeah.
Carlos has like BAML code is interpreted. So BAML code is just code that you write, and then we use that command line tool that Dexter ran, BAML CLI generate, to convert BAML code into native TypeScript code.
Yes. So if I were to actually use the native like VS Code click through, you can see here's the generated code that got generated from this function.
Yeah. And people might be wondering like, why the heck do you use BAML for this?
Yeah, go ahead.
You should probably tell them, but like the main reason I think Dex and I first met is, one, we're just YC founders, but two, the part about BAML that makes it easier for people is just that it gives you full control over the prompt. Like the fact that the entire prompt is accessible to Dexter and he can see it and modify, and there's no default things built in the prompt is where like why it becomes useful. And I think as we do unions, it's going to be a lot more interesting. So let's go on to the next part.
Yeah. And if you come back over this and you go watch the recording, you watch this and then go back and watch we've already done factors 1, 2, and 3, and we're about to do factor 4.
Yeah.
Demonstrated in here. So we'll commit that. Here's the kind of diff of everything that we did. So now we're going to add what I'm going to call the calculator tool. And so this is just, again, a bunch of structured outputs defined in BAML that is the add tool, subtract tool, the multiply tool, and the divide tool. Pretty simple stuff. And then what we're going to do is we're going to update our agent.baml to return either done for now or calculator tools. That's it.
Did you define calculator?
Oh, we need to.
Yeah.
There we go. Oh, it's calculator tools, plural. That's why.
Okay, cool.
And so if we regenerate our code here, now we can ask the agent. We're not even going to change the TypeScript code. We're just changing basically by changing the tools that get passed into here, it changes our prompt. And so this is just prompt engineering right now.
Yeah.
And so now you can see the prompt is going to ask it to answer in any one of these schemas. So I can run and add it. And again, we're not actually doing anything with this output, but this is factor 1. We turn natural language into a structured object that says add 3 and 4.
And this is like the most important part, where the LLM, remember, is not calling the tool. It is simply returning a data model that I then interpret as a thing I can do something with. It's like any other API call. It's just a stateless API call that we were able to convert the model into.
Yep. So here's the only change we made is we added tools and we told the LLM it can return those tools as well.
Yeah.
Now let's actually go process that. So I'm going to update our agent.ts, and essentially now we've updated this to have a full, what we call like agent loop, where, yeah, okay, that looks good. Did we not generate?
No, I think you did. Just press, yeah.
Oh, there we go.
Okay, you probably just didn't generate. There you go.
Okay. So now we're going to get our next step out and we're going to do a switch statement. We're going to say if it's done for now, we'll just return the message. If it's add, then we're going to compute the result. One, we add that to our context window, and I'll show you what that looks like as we go through. And then we're going to push the result onto the context window and we're going to loop again to the top. And we're going to just check now with our new thread, what's the new next step? So yeah.
While Dex runs this and executes this, like one thing to think about is we all see these frameworks. We all see like LangChain's tool calling API. We all see agent API. We all see like the OpenAI API SDK. They're all doing this loop. They're just not giving you control over the loop. Own the loop. Own the loop.
That's it. It's not that hard. So
Yeah.
here's we passed in our first prompt and we got out the intent was add, and then we print our next step and our tool response was 7. We'll turn up the logs in a second. This will make a little bit more sense. And then here's the next context window we put in. We just said
display to not be so dark by chance. Is that possible in your terminal?
I was trying to get it better yesterday. I actually changed a bunch of my colors to work better with the BAML output colors. But you all need a solarized theme.
I will apologize for that. ANSI color art is very poor, as I've learned. Maybe like black.
Yeah, it's not good.
You have black.
High contrast.
Oh yeah, there you
go. You know what? I can't change the profile of an active shell.
Oh, okay. Never mind. Go on. Sorry, folks.
You can run this code yourself in whatever shell you want, though. Yeah. So let me turn this off and I'll just show you kind of how we're logging this stuff out. You can turn it back on.
Oh yeah, we can turn off the logs. That's actually better because then we can see the tooling part of it.
Yeah. So this is just our logs that our application is printing. And so I asked, can you add 3 and 4 and then add 6 to that result? So it emitted this intent, we gave it this result, and then it tried to add them together, and then it gave it this one, and then we have done for now, and it's good.
And you could easily see how we could build a UI off of this. Like pretend that this isn't even an LLM. I think the most important part of the Grok is this doesn't have to be an LLM. I just have a machine that is outputting events, and now I can build a UI on top of this, whether it's a chat bot, chat system, or anything else. And that's all this ends up being.
Cool. I'm going to break this and ask it to subtract things because we haven't actually implemented. We've only implemented add. So if it's not done for now or add, we're just going to blow up with, unknown intent. We don't know what that intent is. So I'm not going to make you all watch me code out the handlers for all of these, but we'll basically pull this into a function called handle next step. And that handles add, subtract, multiply, divide. And so now our loop becomes determine next step, add that to the context window, and then handle next step. So if it's one of our breaking conditions, we'll just return. But if it's one of these 4, we'll fall through the switch statement and we'll do handle next step. And this handle next step is basically going to append the thing to the thread and then return it. Does that make sense? So now we can ask it to subtract 3 from 4. And now we can ask it to multiply 3 and 4. And now we can ask it to do big, complicated things like add and multiply and divide and run through all of this. So that's tool calling loop. There we go. We own our control flow and we can do lots of things. The idea of like the control of when we break and return versus when we continue and loop through, I think is really important and interesting.
So let's look at this code a little bit, just so people can see this a little bit better.
Yeah. What do you want to look at?
Just like maybe we should describe to people exactly what we're doing. So like, how are we doing this?
So our CLI comes through and takes the input message. We build a thread with that message, and then we hand that off to the loop. So that's our base thread. We pass that thread into the LLM. And I'm going to get into testing as the next thing, so we can actually look at what some of these prompts are returning and stuff. But yeah, we pass that into the LLM, we get back a next step. When we push our results on, we want the LLM to know not just what was the result, but also like, what did I call? Because the LLM doesn't know that it called it to. When you pass the context window back in again, it only knows what we tell it. And so we want to be able to tell it, hey, you called a tool that is this next step, that is this, you called this intent multiply 3, 4.
We can turn on the BAML logs again so people can see the full prompt as well the next time we run.
Actually, what we're going to do, just for time, I'm just going to do it in the tests instead.
Oh, even better.
So I've added a couple tests to this file. So here's a math operation here. And so we can pop through here and run this test. And so basically the prompt that we put in was, your helpful assistant, here's the user input, what should the next step be? Cool. And then the
That's a
output
really
was
good.
multiply 3 and 4.
Carlos, that's a great question. Like, why doesn't the LLM know what tool it's called? Unless you put something into the context window of the model, it doesn't know anything. So I could have gotten the answer of maybe add a test case. Do you have another test case that you want to add in?
I have a bunch more test cases.
All right, go on. I'll let you go do that.
All right, cool. Just for the sake of time, and happy to kind of do follow-ups, and if people we have time blocked after if people want to hang out for questions. So we can run these tests now. We can also add what's really interesting here as far as like being able, because your context window and your input is just a string, we can make assertions and basically build really simple evals.
Jinja.
There you go. And like make assertions about what the model returns for certain inputs. So if I change this to add and I run the test again, this is going to fail. So I can run this every time I make a change to my prompts. And then we can also make assertions that like, all right, cursor doesn't know this yet, but that's fine. So we can make assertions about the whole thing that the model outputs.
And the important part here is like, we don't need LLMs as evals. Like when you use structured outputs, LLMs as evals still might be useful. But for a lot of use cases, I just need to know that the intent was correct and the parameters I got out were correct. That's what I need to really nail down.
Yeah. So let's do a test for the long math thing, and this will get to kind of what you were asking for before. I'm going to turn the logs back on just so I can see the prompts that are getting put in as it's going through this. So by the end of this, we have this really long kind of thread as our prompt. And since it's just strings, we can have cursor format this however we want. Great. So this is what we're passing into the model on that last thing. And if we run this test, we'll see that the output was, hey, we're done, and we got our final result. But if we took like a subset of this and we said, let's do...
You want to remove the tool response. Yeah.
Exactly. Let's format this again. Live coding, folks.
And this is like another thing that Dexter was talking about. Like you need to be able to test, like no one knows what's the best thing for your system. The only way you can know is to actually just run the test. And like,
so
here's, go ahead. Carlos asked a question of like, oh, sorry, one last thing. Carlos asked a question of like, an LLM doesn't know what tool it's called.
That's what I'm going to, yeah.
Okay, cool. Go for it, Dex. Sorry.
Yeah. So let's just rewind this a little bit. And let's say that we take away this tool call. So instead of telling it, I mean, it might be smart enough to figure it out, but basically if we just put the tool responses in, I have no idea what this is going to say. I've never tried this.
Right. I don't know. I think that's the best part.
But this is the point, is like, you should be able to try everything. You should be able to see like, actually, it doesn't matter. For a calculator app, the model's smart enough to figure out that we want to add these things. So multiply 3 and 4. And then add 12 to that result. So I think it actually figured it out in this case.
Because it's a simple problem.
Yeah.
And like the model you're using is what model are you using? Can you show the prompt again?
This is GPT-4o.
Okay, cool. Yeah. So GPT-4o is
pretty try switching it to Mini and seeing if Mini fucks it up. But anyways, I hope that answers the question. I'm going to keep rolling just so that we have more, that we can get to all the topics.
Get more covered. Yeah, I want to talk about the more interesting stuff you have lined up too. I know we only have 10 minutes, so let's keep going.
Cool. If I can get my shell back in the right place, we can roll. All right, cool. So here's like the actual like big pile of tests, and now we have a bunch of them. Sorry, we hide the playground here. And so this has a lot of like 5 or 6 longer tests, and I can do PXML CLI test. And so as we're building this, as we find things we're going to change our prompt, we can go through all of that. So I'll commit this. Again, in this chapter, all we changed was agent.baml. We just added a bunch of tests. We didn't write any TypeScript code for that chapter. Cool. Let's add another human tool. So this is where we talk about having multiple different reasons to contact a human. There may be a model saying, hey, I need to request more information. or there may be like an intent that is like, hey, we're done, we have the final answer. And your code might want to handle those things differently. Either display them differently or have different workflows or put in a text box for them to fill out, whatever it is. If you have control over stuff, then you can do it. So I'm going to regenerate off of this and we're going to see how that works. So what I'm going to do is sorry, go ahead.
Auto regenerating every time you hit Command S anyway.
Oh yeah,
You don't have to do
that's
that.
true.
Anyway.
That's fair. I was running this walkthrough from scripts and stuff, so it needed to have it in there, but that's fair. So I'm going to ask it, can you multiply 3 and a bunch of garbled nonsense? And it's going to request more information. Actually, it's going to keep going over and over again because we're not actually handling this in our TypeScript loop yet. We don't have a case in our switch statement for this one. But you can see it's at least output the intent. It looks like there's some incomplete information. So I'm going to come in here and update our agent and basically say, you know, in this case, we're going to handle them the same, which is just to return the message. And they both have a field called message. But you could see us handling those two things differently.
And we're actually able to use like the static analyzer there. So that way, like TypeScript can tell us that they both have the same field message. If you hover over message, like it knows TypeScript isn't yelling at you because the intent of request information has a field called message.
Yeah, because we're in this part of the switch statement, TypeScript knows that it's either one of these two things.
Exactly.
Cool. And then I'm actually going to tweak this a little bit more, where we're going to actually have this return the whole thread, and we'll see why we do that in a sec. But basically, we want to know in our CLI whether when we run the loop, we want to know whether it was request more information or final answer. So if it's final answer, we're just going to print it on an exit. If it's request more information, we can actually like write a function that is like ask human. In this case, it's just on the command line. But this is how you can take two ways that the model may want to contact a human and handle them differently.
Dex, can we slow down for 1 second before we run the code and just
Yeah.
show the data models one last time, just to make it
Yeah.
in the source code?
Yes. In here?
Yeah, let's look at like what these messages are. So we have a class called clarification request, which has an intent attached to it called request with the label request more information. And then there's another class called intent with intent done for now. And if you look at the prompt, can we render the full prompt in the prompt view?
Yeah.
Just so people can read it, because I think there's a couple of questions about this, and let's just like hide the test at the bottom.
Yeah.
And let's just like read this. So you can see the model is kind of letting us output one of those tools, because on line 19, what Dexter has said is that the model can respond with 2 different ways. It can either respond with human tools or calculator tools. And can we hover over human tools? Oh yeah.
Yeah.
Human tools is defined as, we don't hover, oh, whatever. Human tools is defined as clarification request or done for now. So it must be one of those 2 data models. And can you change the data model to, instead of request more information, to be like request foo, just so people can, I think Carlos is having a go down. Just change the line. Instead of intent, use the word like intent, foo, and just change that string really briefly. So you can see that the prompt is updating to mimic that. That's how the model is getting this. We're just writing code, and the code is being added to your prompt. And that's how the model is able to go. You can undo your changes. Yeah, don't do that, but you can undo your changes. And then if you scroll down one more time into the prompt, one last thing I want to show, CTX at output format. That is, can you remove that line really fast?
Yep.
That is what's actually adding the instructions into the prompt. And if you add it back, that's all that's doing. That is taking the return type of the function and injecting it into the prompt for you. And
so that's a nice BAML feature that is basically, hey, based on your return type, what should we tell the model to output?
And then we're just letting the model do the magic. The model is kind of telling us what to go do.
Yep.
Let's go on.
Perfect. I'm going to restore us to where we were. Yep. So we have our loop and stuff. Basically, if the model outputs this request more information, we'll ask for info on the CLI.
You might want to regenerate. Sorry, I think you did because we updated the file and you hit Command S, but then yeah.
Okay. So yeah, now it says request more information. I could say use 12 instead. And now when it's done, it still exits. So we're handling these 2 different request human for info in different ways.
This
How are we
is
doing on time?
this is really cool. And like just for someone, just to re-emphasize this point, this is how you in your chat agent that you're building, you could do this in a website too. Can you go back to your loop code that you're doing where you're actually getting read line? Like where you're actually making the
Yeah,
decision?
exactly. If we have time today, we only have 5 minutes, but if we have time, we can actually, instead of using a CLI loop, we can make this a web API. This is either
Exactly.
synchronous or async.
Like this,
So
this
the agent is decoupled from the UX so that you can plug this agent into multiple different interfaces.
exactly.
And the
So
input to the agent is just a list of events, and the output is
the
a
next
last
event.
event that was event. Exactly. What's the next step? And
Or
it's up
actually
to
in
the
this,
framework can handle it.
in this case, it's actually not it's not the last event, it's the full event thread.
Yeah.
Because then when we add when we get a response from the user, we get the response, and that is now coming from it's coming from just to be very, it's coming from like CLI, but it could come from a web API, it could come from a database request, it could come from an event on Slack. Doesn't really matter. It comes from somewhere. And then all we do, as Dex said, is boom, we just pass it back to the agent loop again on line 29. That's all we're really doing.
Yep. And so then we do it once and then we loop until we get the done token.
Exactly.
This could actually be more clear if we did like not equals
Yeah, but we can do that
for now.
Yeah.
Optimization. Anyways, I'm gonna add some test cases for this behavior because I think it's cool. So now we can see, if we pass in nonsense, and I'm actually going to change this one to be not hex because sometimes it sees hex and gets a little weirded out.
And that's just testing. Like the only reason you know that is because you tested that.
Yeah.
If nonsense is insufficient, it's like, oh, it's too smart. It thinks it will actually think it's
yeah.
hex code.
So we can add evals and guardrails. Now we make sure if the math is garbled, it must request more information. That's what we expect the agent to do. And if someone changes the prompt in a way that breaks that, we will know before that gets merged in.
Because the unit.
And then here's one that shows how it interprets the clarification, right? So we gave it some garbage. And then we said, the model called the tool, which was like, hey, can you clarify this? And then the human responded with, let's try 12 instead. And we can test this one and we can see like, okay, cool. Now it's like listen to the human's feedback, and we can prove that we're passing the human info back into the model in the right way. Yeah. So let's run all of our tests.
I love the word while you do that. I love the word that you use. You use the word prove because that's really what it is. You want to prove to yourself that it's working.
Yep. So one of our tests failed. It was our hello world step. So now we can see, okay, we changed our prompt by changing the structured inputs, but it broke one of our other tests. So let's go look at this. Sometimes you break a test and it's because you changed the behavior intentionally, and sometimes it's because you actually broke something. So if we just say hello to the model, now that we're telling it that it can respond with either done for now or request more information, it's actually decided that if it doesn't know what to do, the correct intent is request more information. So to maintain this and keep it up, I'm going to come and update this test because I actually think that is also the correct answer. It's like the conversation is still ongoing. Yeah. And now we can run this and we can see that it passes.
And by the way, we could have decided that wasn't the case, and we could go back and change our prompt for what request more information means. Can you go back go up really fast?
Yeah, you want to change the
very
thing?
top? I want to change one prompt at the top for your for your request more information.
Yeah.
Add a description to there. The description says to clarify mathematical equations. Yeah.
Yeah.
To clarify math stuff. It's a dumb prompt, but like it's just math stuff, right?
Yep.
Now let's see what the hello test does.
Okay, it's still request.
It did actually change what it said about a math problem, though. It said,
yep,
to clarify existing math problems.
Do not
use
just
this.
Yeah. So you can come in here and mess with this, and you can write tests. But this is a really productive way to make changes and improve your agents over time without losing steam. We have 1 minute left. I'm gonna power through the last bit. Hi Bob, you got 15-20 minutes to go over for people who want to hang out?
We'll stay over a little bit because it sounds like we're getting some really good questions, and we'll record the whole thing and post it on YouTube as well. So including the quick Q&A at the end.
Yeah, folks have to drop. We'll have the recording of the Q&A. Cool. So now we've fixed all our tests, and I'm gonna get out and commit this, and quickly we can review the changes we've made. So what do? We added clarification request. We changed the type of our return to include both of the human tools. We added a couple tests for the using the clarification stuff. We updated our test here so that it passes. We changed our agent loop to return the whole thread instead of just the message. And then we updated our CLI to kind of power that interactive loop a little bit. Cool. Now we're getting into some fun stuff. The next two are really quick, but they're really worth doing, which is like customizing your prompt with reasoning.
Oh yeah.
So I'm going to update our prompt here that we use and basically just give it this, always think about what to do first, like, these steps. If you watched our reasoning episode last week, this should look very familiar. If you haven't, go check it out. But this is a really easy way to get small models to think and perform more like reasoning models. So from here,
while you run this code,
yeah.
A lot of you are like, why the heck are we doing ... Like, what is that? That's not really reasoning. Turns out these models are really, really good at just what we want to tell is the structure of how we want it to reason in some ways, some format that it might use.
Yeah.
And then to go do things, we're not going to prescribe what it should reason about in any meaningful way. That's why we're not using few shot examples. That's why we're not doing anything. We just want the model to be like reasonable on its own.
So I'm going to pass in a little prompt here, and I'm going to turn on the logs temporarily. What? Oh, sorry.
You have like, I was like, what?
It was like trying to do a get operation. I was like, why do you need my keys? So here we have printed out basically this and what should the next step be, and then we have our reasoning prompt. See, it was working yesterday. Sometimes it works, sometimes it doesn't.
I think can make it a slightly more complex thing. Can you add the first 4 digits of pi together? Make that the question that you ask it. No, this prompt is fine. The prompt is just too simple. The model first 4 digits of pi.
Yep.
Now let's go do that. So the model determined that it doesn't need to reasoning at all. That's why I didn't do it. But now,
so here now it's done a bunch of reasoning here. I will perform the calculation, then I should proceed. So now you have your reasoning, and then so it is reasoning each time, and there's probably some stuff you could do to like cache that reasoning basically. But here you can see it's outputting this, and then it has the final JSON here. Yeah. And then what we pull out with BAML, which is also really cool, is just like, hey, we let the model output whatever tokens it wants, and then we rip out the actual JSON and we get the answer.
Yeah, so the user doesn't even have to see the reasoning. We just get the done for now.
And again, I mentioned like, oh, you could cache the reasoning, and it's like, cool, there's all kinds of ways you could do that now that you own the loop and the control flow and customize how you build your context window.
You nailed it.
Speaking of which, let's customize how we build our context window. So there are a lot of ways you can optimize this. But the first optimization I'm going to make is just instead of doing raw flat JSON, like we have been doing here, I'll just stringify the JSON. Probably doesn't make a difference for the model, but this is just kind of a demonstration. So we'll turn on the logs again and we'll give it this answer. And we can see over time, definitely makes it more human readable. So you can see over time, here's what was put in. User input, tool call, tool response, tool call, tool response. What should the next step be? Here's your output. And then it says, cool, our intent is add. And so you can see now it's a little more clear, like as we loop through, the context window is growing and growing and growing, but we still get the same result.
We'll talk about this a little bit more, Carlos. And do you have any more examples of how to serialize the LLM context?
Yeah, dude. We have a really fun one. This is what I do when I build my agents, is I use this thing that's a little more XML-y. And so we have user input, and then as we loop through, we have user input, and then we have multiply, and then we have tool response. The point is, you can do whatever you want to take that list of events in your thread and serialize it for the LLM. So here we're mapping it to this like serialize one event function.
Can you go back really fast? I want to highlight something for people because I think they might not see. You see what Dexter did here? He did multiply A:3, B:4, and multiply. Can you compare that to the JSON one that you had above?
Oh, are we gonna do the token counting thing?
People should look at the tokens. You don't have to. We don't.
Let me drop this in the playground.
Yeah, we should do that. Just add it to your test case. Yeah.
Oh,
It's
come
real,
on, come
yeah,
on.
the serialization is completely up to you. And if you don't own it, you're fucked. Oh, sorry, I used that word. We're recording. I'll bleep it. But
I already did too. It's fine.
if you don't own
You'll
the
fit right in.
if you don't own the serialization, you're really not making life easy for yourself. Because in this case, why are we wasting so many tokens? Yeah, let's just do the prompt view preview.
Okay, cool. So let's look at the prompt preview and we'll look at the
Token view.
this one.
Prompt
So this
view.
is tokens one, and we'll look at another one already has JSON in it, so we can just compare these. So token visualization. Here we go.
Oh, dang, we don't highlight the tokens correctly. I'll fix this.
Hey, I don't think this is right, actually, because I think the XML is supposed to be really efficient, right?
No, it is. We just don't render the escape characters correctly. But just so people understand, is like can you go to the OpenAI tokenizer? I'll fix that, right? I'll fix that in today's release, actually.
Yeah.
Uh,
Is that like a web app or something?
I just go to OpenAI tokenizer. This is like one serialization
So-
technique that everyone should think about is like we can use a serialization technique of what yeah, that's basically the view that we're supposed to have. We just render the quotes, the things incorrectly slightly.
Oh, because this is supposed to be
HTML,
not
yeah,
HTML
as long as I
escapes.
fix the HTML thing, it'll be fixed. So I'll fix that today. But
Cool.
now I'll post a JSON view of it. You have a previous JSON example as well in your test cases.
Yeah, exactly. So let's get this thing.
Just grab anything, it doesn't matter. Yeah. And that's, do you see how every single quote and everything that we're using, every time that we put quotes in there, it's extra tokens. Every time that we put white space in there, it may or may not be extra tokens. The count of white space matters. Because we're using like commas at the end, that's extra tokens. So there's small things that are adding up. And these tokens are not as trivial as like cost. People think about cost. It's just the way that you're explaining the thing to the model. It has to, if Dexter and I were saying the word like and every 30 seconds, you would have such a hard time reading what we're saying. You'd have to like do so much brain power to just understand the nuances of our words. There's just less likes and in that text.
I love that metaphor, likes and ums. That's great.
So you asked like, is serialization customizable? Yes, you can control it to do whatever you want.
Yep. And so now we can add some tests that kind of match this, where we've updated our test to be XML instead. And you can run these the same, and you can make sure like, hey, we changed how we format our context window. Do all our tests still pass? Which is again what you should always be doing. Every time you make a change, you should know, okay, the same input is still the same output.
Exactly. Or exactly. Yes.
Cool. I think we can do you want to pause for questions here? Or do you want to put it behind a web server?
I want to answer Lokesh's question of like, how do you build your first agent? This video that we just made and all the source code is going to be available for you probably within like by the end of the day today. So we'll send it out on email. If you signed up on Luma, you'll get the email. This is probably
we'll also create a template repo with this stuff in here, so you can just kind of pick up the calculator tools and start running with it.
Exactly. All the code we ever do will always be open source for AI that works. Like that's the premise. Like we just want to share code so we can all learn the best architecture designs together. Because as Dex always says, none of us know what the right answer is. We all just need to figure it out. And the best way to figure it out is to test. How about this? Why don't we take some questions in the chat? While that happens, why don't you do the web server stuff? So we'll parallel.
All right, cool.
Web server stuff is so freaking cool.
I remember
me and you were one of the first people to start building out this kinds of things. And I think it like blew our minds as we were building it out. And then like it just became the template for like how I think we both think about agents.
Yep.
So if anyone has any questions, type it out. Dexter's going to do some typing stuff while that happens, and then we'll.
I mean, that's it. That's the web server.
Oh, okay, cool.
So we put it behind an API. What we can do is make this like pause and resumable though.
We can pause and resumable. That'd be sick.
So here we have, I won't go super in depth on the code, but you can go read it. We have a thread store that kind of just stores our things in memory, but this could be Redis or SQLite or wherever you want to put it. And then we basically have this server with an endpoint to start a new thread. This code looks a lot like our CLI code. And basically, if the last data intent is request more information, we add kind of a hook to it to basically tell the client, like, hey, when you have a response to this, post it to this URL.
It's like a
And
web.
then we have
like,
another endpoint that can handle responses.
for people that are familiar with like web interface, think of it like a webhook. Like when GitHub you just register your webhook, and that's what we're telling the front end. It's like when you get an update, and it doesn't have to be a front end, it could be another backend service. It just says when you're ready with the answer, call this API, and we're just telling it.
Yep. So I called with this garbled, and XYZ, and it's requesting more information, and it says, hey, when you have the answer, you can post it back. And so I will post this back, and we will use this thread ID here.
And by the way, this is how we made like a slightly stateful system, but
Yes.
because we saved the thread system in our database, but we could have made it completely stateless by sending the whole object back instead of a thread ID. We just did this because it's a better API experience for the end user, and we can do migrations on the thread and everything else. But this context that we're sharing here today is about owning the loop. If you own the loop, if you own the way that the model is being called, you can build this trivially because you can use existing paradigms that you're already familiar with in software engineering to build your agent, not have to relearn like this LLM voodoo magic to go build your agent.
Yeah, that's all just software.
It's all software.
I think we have another thing that is like, I'll probably do a follow-up or something on like, hey, what if you have human approval, right? You can have a tool like divide is scary. We don't want to run that without checking with the human because we don't want to divide by zero error or something.
You have that up? You should show them.
No, that's not ready to go. I mean, we could try to live code it for the extra lingerers, but we'll send it out. Yeah.
We'll send it out. Or maybe we can do a whole episode on just that, because there's so many nuances to the way that you do human approval that I think it'd be worth
it. It does get a lot more complex. Yeah. So.
And like this is so like what you saw today was a lot around like these infrastructure that we built. This is the philosophy of Baml, and what Dexter is going to share about this human approval stuff is kind of the whole philosophy behind human layer. Like if eventually at some point we'll want one layer of control that we want, because no matter how much engineering we add around these systems, at some point, just like in a normal workflow, you want a manual process to approve it. I don't want my release to be fully automated no matter how good I am. I'm paranoid. I have a human present proof to release it out. So people don't get versions of Baml automatically. It's like a manual process, no matter how good our pipelines are. In your LLM workflows, you'll want that. And that's where I think a tool like Human Layer really, really, really shines. Because no matter how much engineering you do, at some point you want a process because you want liability and other things hooked in. And that's the value.
Yeah, I think you nailed it. So there's much more here, and we can get way more advanced with this. And like probably if we do a follow-up on this, I know by the way, we're gonna take a break for 2 weeks after this. So this has been the kind of first 4 episodes of AI That Works. We'll call it season 1. We'll be back in, what is it, 3 weeks from today?
3 weeks from today.
With season 2. In some point in season 2, we'll probably do a follow-up on this and do like, hey, how do I take my 12-factor agent and put it behind email or put it behind Slack and deploy it to a place? Because if you have this and you have these principles, you can run your agent anywhere. You can run it as a small component of a bigger system, and everything just works.
Go back to your server.ts.
Yeah.
Server, reader server.
Sorry.
Maybe,
there was a thing blocking my my UI.
Making this a Slack API, some of you I'm sure are familiar with it. It's not that hard. Taking that web request and making a Slack API is really easy. So we're going to go into that and talk about the nuances though with AI and Slack, because there are nuances that become different there that are very, very different than just like a normal Slack API. And that's what I think. Like I've seen some of Dexter's work on this. It's freaking phenomenal.
It's funny.
Other questions from everyone, by the way. I know we spoke for a long time. It was supposed to be an hour. We did an hour 15. So I apologize for taking 15 minutes extra of everyone's time.
No. Don't apologize. You're welcome. These people got 15 minutes extra content.
That's right. What questions do people have, if they have any? Feel free to unmute and come on, or just ask on chat. Cool.
So you guys played around with the reasoning models too, and how does they perform here?
So the beauty is, Dexter, do you want to screen share again?
Oh, are we gonna switch on? Are we gonna put on O3?
Make it a reasoning model. Just switch it to O3. The beauty is, remember, what you're doing here, just go to your agent.ts,
Yeah.
make your agent, just make it 03, doesn't matter. 01, it doesn't matter. Like the way,
203 mini, I don't think my verification went through yet for 03, so.
all right, and just do BAML CLI. Yeah, just run a test case.
Let's
It's easier.
do-
Sure. And this is a little bit slower because these models are slightly slower, but now we got it. So and you can see called 03 Mini 2025 131. So it's the model you use is completely independent of this concept. You can choose any model of your choice. And
And you could
lot of-
write this function with 4 different models and run all the models through the same set of tests.
exactly. So then you can decide. And you might say that, hey, as if I want to have like the add tool, then if I want the add tool, then I want to use this model. If I've previously used that, you can make all of this dynamic and it's your choice. And I think a lot of people ask like, how good are people with like using frameworks or anything? Any framework that owns that while loop, that essential while loop, and doesn't give you full access to it, it's like if you've ever used a CSS library, a CSS library that doesn't give you the raw CSS that you can just edit in your code is way more painful to use than ShadCN, where you can just like have it in your code and edit it. And
That's actually, this is, I think, when we build more tooling around this, I basically think what we need is ShadCN for agents. We need something that scaffolds everything out for you with some good opinions and a couple different variations, but then it's your code and you can do whatever you want with it.
You should wait till we release packages for BAML. That's basically what that is.
Okay, sick.
Nice.
This question from Steve.
You've got a question.
Sort of as an aside, but I know a lot of the philosophy you've done in this series of where you say, hey, expected output, and then BAML extracts it out. I was reading the new prompt guide for 4.1 with more literal calls, and it basically sort of says, don't do that, or, a variance of that. I was wondering your thoughts.
Yeah. Bye, Bob. When are you running that new benchmark to prove that BAML's still better at extraction?
Here's what I would really say.
You want to share the BFCL thing?
Okay, I'll share. I'll screen share. There's a couple of things. One, I think there's before I'll screen share. But before I go really into it, I think one important thing to keep in mind for these kinds of concepts. Am I screen sharing? Cool. One important thing to keep in mind is remember everyone's biases. So my bias is obviously I work on BAML. So like be aware of that. OpenAI's bias is they want to lock you into their SDK. Be aware of that. OpenAI's SDK is very different than Anthropic's SDK. They really want you to lock in because then you can't move over. And two, like it's possible that it's definitely possible that it's better, but fundamentally it seems unlikely. And the primary reason that it seems unlikely is that it's just like we run these benchmarks and every time we run them, it's pretty much come out in the same way. Which is what OpenAI says is don't add JSON to your system. And I agree with them. Do not ask the model to output JSON and JSON.parse it. That is bad. That is really, really, really bad. The model will mess up on JSON, especially if you have a bunch of escape characters and everything else. The difference is BAML doesn't actually use JSON. So like in this case, don't use quotes around keys. The model is extracting data from an image. It's not using, you see it streaming, it's not using JSON. This is not JSON. Right? So the premise that's saying that, and you can see like it's pretty complicated. There's a whole string with ands and spaces and everything. It's still pull it out. So
and the idea is that like the engineering work to turn the thing on the left into the thing on the right is not something that you should do. And like if you are not going to write your own parser, you should probably just force the model to output JSON.
Yeah, so if you're not going to do the work that we did behind the scenes, I agree that their thing is probably way better than JSON.parse. Right? And if you're going to do something more sophisticated, like for example, like an idea of like generating code, write me a thing. Right? Like watch this, write me a thing that takes in LeetCode questions, that takes in a prompt and generates code for it and it takes in a text and generates Python code. Right. So what I want is I want to write an AI pipeline that can take in a random thing from a user and like generate some Python code for it. So this will do its thing. And once again, that's just tool calling. This whole thing, like what I did here was this was tool calling that responded to this. This is another tool call that's generating actual BAML code for me. And then this is separate tool call that's generating the Python code to use that BAML code. These are all just tool calls. And all I'm doing here when I go do this is if I were to go, and I'll do this in prompt fiddle because it's a little bit easier to go see. So
Man,
when I go
really
run,
use these tools a lot, huh?
huh?
This is impressive. You're very quick with this stuff. I gotta learn. I gotta jump between these faster.
So now it's going to go run the code, right? So now it's going to generate Python code. And check this out. See how the model did it? It just responded with a Python code snippet afterwards as a markdown snippet, and it produced this out. So you're right, JSON is bad. But serializing it in a way that the model can output things and I can go parse it is useful. And
This
if
is
I
getting to that point of like the model's been trained on a lot more code in Markdown than code in JSON. And so if the
Exactly.
model wants to write code in Markdown, you should let the model write code in Markdown. And then that will give you better results than constraining its output and forcing it to use like /ns and saying, hey, you can't use new lines, because then every time the model wants to output a new line, that token's going to get zeroed out. And all the other tokens, which were all like 1% in the sampling, it's just going to pick a random one of those instead. And the chance that it picks /n is like very low.
Yes. Dexter nailed it. So OpenAI's guideline, I agree with. JSON is bad. But I'm still not convinced that tool calling is good, because tool calling is basically doing JSON in a forced way. And there's no way you'll get this large quality of code out. And the model did this naturally. This isn't me prompting in any way. I just like the prompt says this. This is all the prompt. That's all. This is a web request going into the model. There's no tool calling, nothing else. And the model is naturally able to say that the best way I want to output these tokens, the tokens that are best for me to represent this data, is this.
Yeah, that's some trash JSON. Good job parsing. It's a good ass parser, dude.
That's a good ass parser.
Cool. I gotta get running.
Let me just stay on for any more questions that people might have, and then I think we're mostly done. We don't tell the model how it outputs. We tell it the structure that we want it to go have, and that's mostly it.
So whatever it outputs, your parser sort of like
It mostly works.
take the adjustments.
We've processed like tens of million. I don't even know. Like I have no idea how many data models that we've gone through at this point. But Dexter's pushed a lot of limits of them with his tool calling systems a lot, along with a bunch of other companies, and it's made it. The benchmarks show that it's good.
But wouldn't different LLM models sort of like lean towards something different?
Yeah. So you can just use a different model, and it mostly works because it's a very unrestricted parser. And there's like, you can read our blog post about it, and they'll probably outline it a little bit better.
That's cool.
Any other questions from anyone else left? I know there's a few people, and then we'll call it quits, and then me and Dex have other meetings to attend to.
So, what do you think about the MCP and the agent development kit? Do you plan to use it in your products, or how do you plan to integrate with them?
You want to go first?
Okay, this is not on behalf of Dexter. This is my personal opinion of it. So just to be very, very clear, and I don't know what Dexter's opinion is. I don't think we've explicitly talked about this.
It's complicated.
Yeah, I think all those frameworks are basically just like API calls around REST endpoints. And like they have some way to do REST endpoints. And I guess they've made some decisions around it, but I'm not yet convinced that it's the perfect decisions. I think like LangChain, for example, was very hyped for a while and clearly doesn't work because of engineering constraints. And not really because like, I mean, there's value in LangChain too, but like LangGraph is, I think, more thought through than LangChain is for example, what I'd say. I think MCP is, I wouldn't build a company on it today, is what I would say. I think it's in Anthropic's best interest for MCP to get adopted because they're building UIs that everyone uses and they want to have a standardized way for people to plug into their UI with them doing less work. They're kind of using MCP as a way to build and bootstrap an app store, is the way that I kind of think about it. But I'm still not. I think when I look at code, what I look for is beautiful code. And that's why I decide if something is good or bad. That's like when I first saw React, it honestly felt beautiful. Like it was like, it's actually really pretty once you understand it. And I don't look at it. When I look at LangChain, it doesn't feel beautiful. That's why I didn't like it. When I look at Pydantic AI, it doesn't feel beautiful. There's things about it that feel a little off. When I go look at MCP, I had the same feeling. I don't look at it and be like, wow, that's beautiful code. And that's kind of why I'm not personally like 100% bullish on let's go do this today. It might prove to be amazing, but I don't think it's beautiful today. And beauty is really important in code, especially for frameworks and systems.
Cool. Wait, no, I'm gonna give my MCP rant, and then you're up, Carlos. I think protocols are very powerful. I think we saw a similar thing play out in the Kubernetes world, which was basically like you had this thing called Helm, which was like super scrappy and didn't have, I think, probably arguably all the right abstractions, but it was at a level that people could understand it. It was good enough for people to adopt and move on to the next thing. And once it got momentum and everyone was using it, it was basically locked in. And it didn't matter that Google came along a year later and released like a much better solution for the problem, a much cleaner protocol, much more well thought for, much more like engineer friendly. It didn't matter. It had already taken off. So MCP may be the thing that we're not stuck with, whatever you want to call it. I think REST is pretty good already. Not 100% sure why we needed it. There's a lot in it. But we are building stuff on top of MCP. I want to build a BAML agent that queries MCP tools and pushes them into the context window as tools because I'm curious how the actual performance is. Because if it's an easy way to consume APIs, then I would probably use it.
Exactly.
Even if it's not perfect.
MCP is basically a REST service that has a very specific query that you can make that says, tell me all the other services you have. That's it. And that sounds useful.
Yep. And the other fun thing, if you want to mess with people, is MCP servers. Most of them are actually clients. They're not servers. You don't call them over the web. You run them locally on your machine, and then they make the call to a real server. But we won't get it. That's just a naming thing.
Carlos, you had one last question.
Yeah, you sort of answered that question. I was going to ask whether the BAML can be integrated with MCPs, and I guess Dexter, you're working on it.
If you watch the first,
well, Elias is working on it a lot more, but we should do an episode on that. Bob, we should be like, how do you integrate MCP with the 12-factor?
Yeah,
yeah,
go do that. I think that'd be a fun one. I think especially for like the next season, we'll go. One thing we're gonna go do. I know a few of you are left. We're gonna go send out a survey at the end of this with this episode. If you have time, we'd love like a detailed response to it. It will just help us tune the next few things, and then it will start every Tuesday after that. And you should expect to see this detailed code examples pretty regularly with Dex and I.
Amazing.
All right,
thank you. It's been a blast. Thanks, everybody.
And then we'll stop the recording.